Hello everyone, my name is Mohammed Imran Ansari and welcome to the DevOps. So every modern tech, every modern technology we talk about today, cloud, Kubernetes, AI, DevOps, stands on one invisible foundation, and that is networking. If networking is weak, the entire stack collapses. But if networking is strong, nobody even notices it exists. So the most important thing here we'll talk about is the DNS, which gives direction, the HTTPS, which builds the trust, the Kubernetes services, which gives the scaling. And today I won't teach you any networking as definition. I will walk you through a real request live journey end to end. Every interaction begins with a single request. I'll tell you a story. Think about the last time when you clicked today. It could be a login button, could be a dashboard, or even a YouTube. Every click is equals to one or multiple requests. The request which travels through the browser, to the internet, to the cloud, to the Kubernetes cluster or any other server, and then finally at the pod level. Complex systems don't start complex. They start with one small request. If you can debug one request, you can debug any outage which you face. Let's talk about what really happens when you type a website name and press enter. What does your browser magically does? Do you know where does it go? Browser has no idea what google.com is. The internet routes through numbers, not names. The entire journey happens in milliseconds, which is why it feels like magic. The first question the internet asks is very, very simple. What number does this name represents? The lookup from a name to number. This is the moment where human language meets the machine language. Names are understandable by humans, but the IP addresses are understandable by the machine. No lookup is equals to no routing. No routing is equals to no websites. DNS is not optional. It is a mandatory infrastructure. The DNS is also referred as the phone book of the internet. DNS does not host websites. DNS only tells you where they live. So DNS doesn't bring food to your house. It only tells the delivery guy your address. Site down in incidents are actually DNS misconfigurations. Let's walk in step by step through a story. Now your browser asks the local resolver. When you type in www.google.com, the browser asks the local resolver. The resolver asks the root servers. The root server says, okay, it's .com. Let's point to TLD. The TLD points to authoritative server. And then finally, the authoritative server returns the IP. If you see it in the Kubernetes context, inside Kubernetes, the core DNS does the same job. But for services and pods, DNS exists at every layer, whether it is internet or a Kubernetes cluster. We'll also talk about a few basic nomenclature, which is the key record types. The A record, which maps the IP4 addresses. The AAA records, which maps to IP6 addresses. The CNAME, which usually maps to alias or another domain. CNAMEs are like alias to another domain or subdomains, right? For example, if you have play.google.com, maybe mail.google.com, docs.google.com, sheets.google.com, all these subdomains can be added as a CNAME. Now, MX, mail exchange records for email routing. Most of the websites have MX record systems like email.maybe your customdomain.com, where it is used as a mail exchange records. Then you have TXT records. These are TXT records usually done for verification token. You might have seen when you're trying to verify your domain on some websites. So what they do is they give you a token which you add into your TXT records, and once they hit a request, find that token in that particular TXT request, they verify you as a domain owner. So yeah, that's one thing which is very, very important. Now in cloud and Kubernetes context, services like AWS Route 53 or Cloud DNS acts as an authoritative server for your domains, and the Kubernetes discovery, the core DNS, as I mentioned, is inside the cluster, allowing the pods to find these services inside it without hard coding IPs. Okay, so that's important. Let's understand this layer by layer. You see the 4 layers right now: the link, the internet, the transport, and the application layer, right? So this is the mistake what junior developers do. They start debugging things from the application layer. No, they should start from the bottom, which is the physical layer, and see if it works up. right? Let's talk about how exactly these things works. So the application layer is something where you are actually using a browser, where you're sending the request in your application. It's usually defined by protocol like HTTP, gRPC, and DNS. Then it comes to the transport layer, where you have your TCP handshakes, UDP, which fires and forgets. And this is something which your data is being, and here your data is being chunked into segments and which are ready for transmission. Then you have the internet layer, where you talk about addressing and routing, the source IP and the destination IP. Now, this handles a lot of VPC, CIDR plannings, subnets, route tables, etc. Here, the packets are created and packets is labeled where exactly it needs to be delivered. Okay. Then you have the physical transmission, which is the link layer, which is the lowest layer, where you have the Ethernet cables, Wi-Fi radio, etc. Now, this is the host which connects to local or virtual networks. Now here, if you see, your actual data is converted into electromagnetic waves, and which is something which is understood by the underlying hardware. Now let's talk about establishing trust, right? Establishing a secure link by using the handshakes. Now, when you meet someone, you don't start a conversation by sharing your secrets, right? You first confirm who are you talking to. The TCP handshakes establishes connections, and TLS handshakes establishes trust and encryption. Now, there is a key message here which says no handshake is equals to no conversation. Now, here comes the very important terms HTTP and HTTPS. Now, HTTP is transparent, it's quite open, and HTTP is like an encrypted tunnel. Like you can see with one of the ideology which says, hey, you're sending a letter which is open, anybody can read it, you can do through HTTP, and something which is, or maybe shouting in public, which is HTTP. But when you are whispering in a locked room or sending a letter packed, sealed in an envelope where nobody can eavesdrop, that's the HTTPS. Modern browser don't trust HTTP anymore, and neither you should. You should always make sure as a DevOps practice that HTTP requests are converted into HTTPS by default. Let's talk about what HTTPS guarantees. It guarantees encryption, guarantees the it guarantees the identity verification. It guarantees the data integrity. Now, as a DevOps practices, as I mentioned earlier as well, always have a habit of redirecting the HTTP traffic to HTTPS. Automate the certificates. You can also automate or monitor the expiry so that your certificates are expired and you are aware of it. And make sure security that relies on manual step will fail. So try to automate as much as you can. Now let's talk about the firewalls. Firewalls can be considered as a gatekeepers or like a bouncer outside your castle, right? Now think about it. Firewall is a rule book. We call it as a wall, but it's firewall, but it's not a wall, right? It's a rule book. Now you have IP based rules, you have port based rules, you have protocol based rules. Security is about control, not paranoia. Okay, so here if you see, you have bouncers at each and every door. Nobody can enter the castle through the windows or the door unless they are allowed to. So once they reach, they will be asked by the bouncer, hey, what's whether you are authorized, whether you are at the correct place or location, whether you are authorized to go further, and that's how it will be. So now you have one IP, but you have many applications. Now it's like one castle but many doors, and the ports needs to decide who gets the request. So basically, who is allowed through which door. Maybe I am allowed from the front door, so I'll be allowed through that, but maybe somebody else is only allowed through the back doors, right? In this case, we have divided these things into multiple ports. So you have one IP, but every entry, for example, SSH can be only done through port number 22. DNS port number 53, secure web traffic 80, and secure TLS web traffic through 443. If you have to access the MySQL database, you need to come through the port number 3306, and that has to be opened on that particular server. It might happen so because like we have around 65,535 available ports, and trust me, every port is not open by default, right? Similarly, if you see by the Kubernetes context port mapping, you have the node port which is from the range 30,000 to 32,767, right, which goes to the service by on port number 80, which goes to the target port or port which goes to the pod or the target port at 8080, and which in turn goes to the container with on the container port, which is mapped, could be anything, but usually 8080 for the web applications. Now, passing the gatekeepers, and now let's talk about this slide. So if you see, there are scenarios. You have ingress rules, you have egress rules. So anything which is coming inside is called ingress. Any traffic which is going outside is called egress. So make sure you understand these two concepts very carefully, right? This is very important. Now, everything is denied by default, and that's called the principle of least privileges. The default rule should always be deny all. Only explicitly allow that what you need. Don't leave the internet or 0.0.0.0/0 open, right? So if you see this rule engine in action, right, the firewall control who can talk to whom. For example, the internet, there is a request on port number HTTPS. Yes, that is allowed. They can go to the web application, request data from there. Hacker is trying to go to port number 22. That's blocked. That's blocked. He cannot, or he or she cannot do that SSH through that. And similarly, if you have to, access the database, in case the web application is trying to access the database, they can do through the port number 5432. That would be allowed. So the most important thing here, we'll see in further sessions, but here it is about cloud security groups. Make sure that the stateful firewall applied at the instance or VM level, and automatic return traffic allowance is also allowed. Now, KTS network policy is also very important. The NetPol, where the stateless firewall applied at the pod level, default allow unless policy exists. Now, we have one more problem to solve. Now, we have one server where a lot of traffic is coming. We get the bottleneck, right? Now, if one failure happens, there is a complete outage. So the better part is you need to make sure that you distribute the traffic and hide the backend complexity completely. How will it be done? So here comes the load balancers. Load balancers don't only add performance, but they protect the availability. Here, if you see, we have a visual diagram where you see a lot of people are requesting the data or your website, and your website is hosted on this particular container Kubernetes cluster where you have multiple pods, right? And in between, you have our hero called the load balancer, right? The load balancer job is making sure that it flows through the healthy system, right? That is the most important thing. Try to flow only through the healthy system, and that's called the resilience. Now, when it decides the healthy systems, it does a lot of things, like it does a regular health checks, right? If you see, it checks whether they are getting a 200 response from that particular server by pinging the endpoint. Usually it is health, but you can also have some other endpoints which you can define as your health check. Now, there are also algorithms how the load balancer decides the traffic. Maybe, for example, here there was no chance because it is already health check failed. So the load balancer will not send the request. But based on these two, it will try to see based on their algorithms, right? So there are few algorithms. One is round robin algorithm, which cycles through server sequentially. One will go to pod A, the other one will pod. The other one is least connections. It sends the traffic to the server with the fewer active connections so that it balances the request. And then you have IP hash, which is also called as sticky sessions, because which ensures that a user keeps hitting the same pod or the same server in order to maintain that session intact. This is how it looks like. Now, if you see from this sanctum, navigating the Kubernetes network, how the data from pods to Kubernetes is flowing. The pods are temporary, services are stable, Ingress controls the entry here, right? And then the most important thing here comes is Kubernetes solves networking by decoupling the identity from infrastructure. Now, how does that happen, right? Main entry comes to the ingress controller, right? The ingress controller defines which service it needs to send the data to, request to, it needs to send the request to. Then the service decides which pods needs to be called based on the connections which it has or the labels. Now let's put all these things together. Now we understood the whole journey into pieces. Now let's talk about one request. Now your DNS finds that request. The HTTPS secures that request. Your load balancer distributes that request. Your ingress controller routes the request. Where is it going? Your services selects where it should go on which pod, and then your pod finally process that particular request. Now, this is not magic. This is just engineering, a marvelous engineering. Failures are inevitable, but panic is optional. Always make sure that you have these checklists. Start from the DNS, move to layer by layer. Make sure that you use tools and not assumptions. Great engineers don't fix symptoms, they understand the symptoms. Always ask these simple questions. Whether my domain is pointed to the correct load balancer IP, my certificate, whether it is valid, whether whether the TLS handshakes are successful, is my port 443 allowed in my inbound traffic? There might be chances it might not be, it might be missing, right? You need to open that up. Are my health checks correct? Are they hitting the right pods in the backend pool? All these things are very important. You can use these commands also, or these tools, dig tool, etc., to make sure how your request flows from the inception to the end result.
If you found this video useful, please do like, share, and subscribe. Comment DevOpsy and I'll share a real network outage troubleshooting guide. See you in another episode of the DevOpsy.